Okay. Chapter 4.4 and 4.5, the questions are kind of difficult. So I solved most of the questions. And for first one, it's the question 4. To find the limit of this function when x goes to negative infinity. So you have to pay attention to is x goes to negative infinity or goes to positive infinity. And for this kind of questions, both the numerator and denominator has a x. The common way to solve this kind of question is first to find what is the highest power of x. So we can see the first term x is to the power 4th, and second is x to the power 2, and third is x to the power 5. So the highest is x to the power 5. So after finding the highest power of x, we let both the numerator and denominator to divide by the highest power. So we let both numerator and denominator divided by x to the power 5. So the first term divided by x5, what's left is 11 over x. And for the second term, 7x squared divided by x to the power 5 is 7 over x to the power 3. And for the denominator, 5 over x to the power 5, what's left is 5. And for the fourth term, 8 is 8 over x to the power 5. So here x goes to negative infinity. When x goes to negative infinity, first term goes to 0. 11 goes to over infinity, is just a 0. And second term, 7 over x cubic, when x goes to negative infinity, this term also goes to 0. And the same for 8 over x to the power, x goes to negative infinity, so this term also goes to 0. So what's left is just a 0 over 0 divided by 5 plus 0. So it's 0 over 5, which is 0. And for question 5, the given function is f(x) equal to x cubic divided by x squared minus 36. And to find the vertical asymptotes, we just let the denominator part equal to 0. So x squared minus 36 equals 0. So we can find x can be positive negative 6. And b is to find where is the local maximum and the minimum. So this is the extreme from first section. So those values can only occur at either an endpoint or the critical point. So we need to find where are the critical numbers. To find the critical points, we set the first derivative to be 0. So you just solve the first derivative of the f(x) and set it to be 0. And then you can find two values. One is the negative square root 108, and one is the positive square root 108. So one is the minimum and one is the maximum. And for CD, that's to find where is if the f function is increasing or decreasing. So let's check if first derivative is positive or negative. And then check it's concave down or concave up. You need to use the second derivative rule. And for the inflection point, so we know inflection point is where the graph changes its concavity at. And actually from D, it's concave interval, you can find it's from some number to 0, and another is from 0 to some number. So as the concave down, one is concave down, one is concave up. So at 0, it will change its concavity. So that's why its inflection point is 0. And for number 7, to find the limit x goes to 6 plus e3 over 6 minus x. So first is we need to find where is the x goes to 6 plus 3 over 6 minus x. So that's to the power e to the power something. And we know from the for this function there is a asymptote, vertical asymptote, that's x at 6. So x at 6. And for x approaches from the right side to 6, the curve goes to negative infinite. So that's why this term goes to negative infinite. And from the slides of the chapter, there is a term when limit e goes to negative infinite equal to 0. Actually, exponential function looks like this. So when x goes, when the power of e, so this is ex. When x goes to negative infinite, the limit goes to 0. So that's why the answer is 0. And for number 8, part B, its limit x goes to negative infinite 7 over e to the power x plus 8, because x goes to negative infinite. So from the graph here, you can memorize this graph of exponential x. It's an increasing function. So when x goes to positive infinite, it goes to infinite. When x goes to negative infinite, it goes to 0. So that's why when x goes to negative infinite, this part go to 0, but 7, 8 keep the same. So that's why the answer is 7 over 8. And for question 9, and this is a function, and we can simplify the denominator part. So that's a quadratic form. We can write it as x plus 2 square, because when we expand the x plus 2 square, that's a plus b square. So that's a square plus 2ab plus b square. And because x plus 2 is on the denominator part, so x cannot be negative 2. And x equal to negative 2, that should be our vertical asymptote. So the graph should be like this. So there is an asymptote, then negative part increase, and for both negative and decreasing part, they should be increasing. And for x goes to negative to 2 from the left side, this is negative 2, and the function goes to positive infinite. But when x approaches to negative 2 from the positive part, it goes to the negative infinite. So because the negative limit and right limit does not equal, so that's why the limit does not exist. And for number 10, A, B, C are easy, but for part D and E is kind of tricky. And for, as we can see from previous examples, so from the first example 4, I said if both the numerator and denominator has x, we need to find where is the highest power of x and then let both numerator and denominator to divide by the highest power of x. So here, for this one, both numerator and denominator has x. So what is the highest power of x? And we can see it's x squared, right? But don't forget there is a square root of outside it. So it's a square root of x. It's the absolute value of x. So we need to let both numerator and denominator to divide by square root of x squared. So both the numerator and denominator divided by square root of x squared. For the numerator, because this is a common square root, so which x squared plus 12x. So after division, x squared over x squared is 1 plus 12 over x. And for the denominator part, it's 3 minus 14x over square root of x squared. Because x goes to positive infinity here, so it goes to a positive number. So we know for positive number, absolute value of x is just x. So we can let this become x. So 3 over x minus 14x over x. So 3 over x minus 14x over x is 14. So what's left is top part, denominator part is square root of 1 plus 12 over x, and numerator is 3 over x minus 14. But x go to 0, so go to positive infinite. So 12 over x go to 0, and 3 over x is also go to 0. So what's left is square root of 1 plus 0 divided by 0 minus 14. So that's negative 1 over 14. And for the part E, the only difference is x goes to negative infinite. Because x goes to negative infinite, so x will become a negative number. So absolute value x should become negative x. So the same for both numerator and denominator. We divide it by square root of x squared. So for the numerator part, it's the same. But for the denominator part, it's 3 minus 14x over square root of x squared. And we know square root of x squared is the absolute value of x, but x becomes a negative number. So it's 3 minus 14x over negative x. Don't forget the negative sign. So after simplification, x goes to negative infinity, this goes to 0, and this also goes to 0. So it becomes a positive 1 over 14.